Hello everyone and welcome back to Math 143 Finite Mathematics. In the previous lecture, we learned how to multiply matrices and how to write systems of equations in matrix form. Today, we are going to answer an important question. Suppose we have matrix A. Can we divide by that matrix just like we divide by a number? The answer is yes, but only if the matrix has an inverse. So today's lecture focuses on determinants and inverse matrices. The learning objectives are by the end of today's lecture, you should be able to compute determinant of 2 by 2 and 3 by 3 matrices, decide whether a matrix is invertible, find the inverse of 2 by 2 matrix using the formula, verify your answer by multiplication. Okay, let's start with the review. So, I wanted to know that what number or numbers leave multiplication unchanged. The answer should be number 1. So, the matrix equivalent of the number 1 is the identity matrix. I hope you remember that. The matrix equivalent of the number 1, the identity matrix. Okay. Also, then the matrix equivalent of the reciprocal is the inverse matrix. The matrix equivalent of the reciprocal is the inverse matrix. Okay, then what is an inverse? What is an inverse? Okay, so I hope you remember that by multiplying the identity matrix by the matrix itself gives us the matrix, right? So then we can define the matrix A, let's say matrix A times A inverse, or A inverse times A equals I. So you can get it from here. A times A inverse equals identity matrix. If multiplying two matrices, so here we have A and A inverse, two matrices, right? So if multiplying two matrices gives the identity matrix, then one matrix is called the inverse of the other, right? So that means here we have matrix A inverse, then we will get the identity matrix. So let's say A is 2 by 2, inverse matrix is also 2 by 2, here 2 by 2 identity matrix. So when we multiply a matrix by its inverse, we obtain the identity matrix. On the other hand, we can say that when we multiply a matrix by its inverse, we obtain the identity matrix. Okay, next. What is the determinant? Okay, let's see. Determinants. Before that, I wanted to ask, does every square matrix have an inverse? Does every matrix have an inverse? No. So to have an inverse, the matrix must be a square matrix, but not all the square matrices have an inverse. Okay, does every square matrix have an inverse? No. Right? So to determine whether an inverse exists, we first compute the determinant of the matrix. To determine whether an inverse exists, we first compute the determinant. Okay, so I mentioned that the determinant only calculate for the square matrices. Let's start with the 2 by 2 matrix. Determinant of a 2 by 2 matrix. Okay, let's write. Write the matrix A is a 2 by 2 matrix A, B, C, D. The determinant is calculated by multiplying along the main diagonal and subtracting the product of the other diagonal. Subtracting product of the other diagonal. Right? Okay, let's see. The determinant is calculated by multiplying along the main diagonal and subtracting the product of the other diagonal. Right? So then write the determinant of A. Also say that the determinant of A symbolically. Multiplying along the main diagonal values A times D minus the subtracting the product of the other diagonal C times B. So be careful, the students often forget the subtraction. Therefore, first multiply along the main diagonal, AD, right? Then subtract the product of the other diagonal values. Let's see the example. Example. Find the determinant of 3, 2, 1, 4, 2 by 2 matrix. Let's walk through it. The main diagonal here and the other diagonal here. Okay, let's use red for the main diagonal. Three times 4, 12. Let's use blue for the other diagonal. One times 2, 2. Then the determinant of A should be 12 minus 2, 10. Right? So now we are going to make a quick note. So that is if the determinant of the matrix is not zero, non-zero, not a zero or non-zero, non-zero, the matrix has an inverse. The matrix has an inverse. Right? So the matrix has an inverse means the matrix is invertible. Invertible. Very important, right? Okay, then here you can see the very important note, right? Okay, then let's move forward for one more example. Example, find the determinant of 2, 5, 4, 10. Okay, take the main diagonal and subtract the other diagonal. Determinant, let's say A, matrix A, 2 by 10 minus 4 by 5. 20 minus 20, 0. Okay, the determinant is 0. If the determinant is non-zero, then the matrix has an inverse. The matrix is invertible. But if the determinant is 0, if the determinant is 0, the matrix is singular. We say that the matrix is singular. Singular matrix. The matrix is singular, which means it does not have an inverse matrix. Which means it does not have an inverse. It does not have an inverse. Okay, let's go for the new example then. Okay, let's say the matrix A 1 3 2 6. Okay, pause the video and find out the determinant and answer the question, have an inverse. Okay, compute by yourself. Okay, check the answer then. Here you can see the same examples. Determinant of 2 by 2 matrices and the same thing what we discussed. Okay, now determinant of 3 by 3. We can also compute determinants for larger matrices, right? So, but it's too much complicated. Here you can see the determinant of 3 by 3 matrix. Here you can see the determinant of 3 by 3 matrix. How to find then? So, first we wanted to get this. First row, first column. Then take the first leading value A times, now we have what? Now we have a 2 by 2 matrix remaining here, right? A times determinant of that 2 by 2 matrix, right? Then minus, do the same thing, right? Do the same thing. Now second row and this first row and second column, sorry. Then b times the determinant of other remaining D, F, G, I. Also plus then first row, third column, we should get C here. C times determinant of plus C times determinant of other remaining 2 by 2 matrix. Then you will have A times the diagonal EI minus HF minus B times DI minus GF plus C times DH minus GE. The 3 by 3 matrix. Okay, let's see the example here. So please make sure to pause the video and try to understand the steps. Okay. First we have the first entry here. 1 times determinant of 1460. Next, minus 2 times determinant of 0450. Next, plus 3 times determinant of 0156, right? Then easily compute 1 times 0 minus 6 times 4, like this, negative 2 times 0 minus 20 plus 3 times 0 times 6, 5 times 1. So 1 times negative 24, negative 2 times negative 20 plus 3 times negative 5. Finally, we have negative 24 plus 40, negative 15. The determinant is 1, equals 1. Okay, I hope everything clear so far. Again, what two things must be true for the available for the inverse? Matrix must be square and determinant must not equal 0. Conditions for an inverse. First one, matrix must be square. Second, determinant not equal 0. Okay, then let's say the formula for inverse matrix. To find out the inverse, the formula. For a 2 by 2 matrix, let's say we have a 2 by 2 matrix, matrix A, B, C, D. First, find the determinant. First, find the determinant. Next, switch the diagonal entries. Switch the main diagonal entries. Also, change the sign of the off diagonal entries. Finally, divide every entry by the determinant. Right? Here you can see the formula which I have talked, but let's see. We have a matrix A, B, C, D. The first step, find out the determinant of A. To find the determinant, Multiply the main diagonal, subtract the other diagonal value, product of the other diagonal, AD minus CB. Next, switch the main diagonal entries. Switch the main diagonal entries, then DA. Also, change the sign of the off diagonal. Negative B, negative C, because we have positive C. Then, divide every entry by the determinant. Like, then A inverse equals divide every entry by the determinant. Okay, let's see the example. Let's see the example. Here we have the matrix A, 1, 2, negative 1, 3. Compute the determinant first. 1 times 3 minus negative 1 times 2. 3 plus 2, 5. Then, next, A inverse could be 1 over 5. Switch the main diagonal values and change the sign of the other diagonal values. And finally, divide all of them by the determinant. That means 3 over 5, negative 2 over 5, 1 over 5, 1 over 5. The A inverse. If you wanted to verify the answer, use A times A inverse equals I. Take the product of this A and A inverse and check whether that it will give us the identity matrix, 2 by 2 identity matrix, because we have a 2 by 2 matrix in our matrix A. Okay. Let's see the method to find in the inverse of square matrix. To find out the inverse of the square matrix, we can define the matrix and its inverse. A and A inverse. We don't know the entire values in A inverse. But by the definition, we know that A times A inverse, by the definition, we know that A times A inverse will give us the identity matrix. By multiplying these two, we will get this. So multiplying the matrices, you already know how to multiply the two matrices. So then we can compare the corresponding entities. So here finally A plus 2C equals 1, B plus 2D equals 0, negative A plus 3C equals 0, and negative B plus 3D equals 1. By solving these equations, you can get the values for all A, B, C, and D. Solving, you can get the values. Check the steps. Now you already know how to solve the two equations by adding, subtracting. Check the steps given here and you can get the values. So the A inverse, we can get the D here, A here. C here. And get the B also. Here we have B. This should be B. Right? Finally, the A inverse is here. So by the definition of the inverse matrix, we can say that A times A inverse definitely gives us the I. Then by multiplying, assuming the A inverse is this, using the symbolical form, you can get the identity matrix and compare the corresponding coefficients. Okay. The finding an inverse using augmented matrix. So first write the augmented matrix, like in the left the matrix A and the vertical line afterward the identity matrix. Then do the row operations until you get the right side is I and the other side you will get the inverse matrix. Right? So you can see that the given example here, try it by yourself. So let's start with writing this A2153 and that corresponding 2 by 2 identity matrix. Do the row operations. Check the answers by yourself. Okay, now we have the identity matrix here and A inverse. Therefore, the inverse of A should be 3, 1, negative 5, 2. Okay. Then here are several exercises. Pause the video and try it by yourself. So given matrix A here and the A inverse can be calculated by using the formula. Also definition, also using the augmented matrix. Find out the A inverse using either of the formula or definition or augmented matrix, and at the end check your answer with the solution given here. Okay, then next, solving systems of equations with inverse. So we know that and we discussed that. So we can represent the systems of equations using matrices, the coefficient matrix, variable matrix and the constant matrix we discussed in the previous lessons. So solving the matrix equation if matrix A is non-singular, that means it has an inverse, we can solve for A by multiplying both sides of the equations by A inverse, right? So in general, we can say that we have A times x equals B, then multiplying both sides by A inverse. What happened? A times A inverse, identity matrix times X, A inverse times B. We know that the identity matrix behaves like number 1. Therefore, X equals A inverse times B. A inverse times B. Let's look for the example. Here, let's write the system of equations Ax equals B. A, the coefficient matrix, 2, 1, 1, 3, 2, 1, 2, 1, 2. X, the variable matrix, x, y, z, equals the constant matrix 1, 2, negative 1. Okay, we know that x equals A inverse times B. Now, first we wanted to find out the A inverse. A inverse, to find the A inverse, I would prefer to use, this is a 3 by 3 matrix. I would prefer to use the augmented matrix one with the row operations. Try it by yourself. We will get 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. Right? So, the A inverse equals 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. So, the solution x equals A inverse times B. Now, we have two matrices, 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1 times the matrix B, 1, 2, negative 1. Matrix multiplication, 3 by 3, 3 by 1, definitely will give us, what will give us a 3 by 1. It should be 0, 1, 0. That means x equals 0, y equals 1, and z equals 0. The solution set. Okay. I hope everything clear so far, and here you can see the end of section exercises. Please take your time and do the exercise. Pause the video and do the exercises. And check your answers too. Okay, let's review today's lesson. So today we learn what determinants are, how to determine whether a matrix is invertible or singular, how to compute determinants, and how to find the inverse of 2 by 2 matrix. Also we did how to find the inverse of matrix using augmented matrix, and the system of linear equation, find out the solution for the system of linear equations, right? Okay, the content is too big for the section 2.6, but hopefully you can understand the section. Okay, this chapter 2 now done, so let's move forward for the chapter 3, and I will see you